this is trigonometric ratios for 32B. We are going to be applying what we just did in 32A with our trigonometric ratios with sine, cosine, and tangent. If you notice in our triangle, we only have 2 side lengths. So before we get started with our ratios, we do have to find that third side length. If you remember back to concept 30, we learned Pythagorean theorem. So we are going to apply that to find our third side length since we have a right triangle. So our A we're going to use as our 8. We are trying to find our B value, and then we have our hypotenuse is 10. This would reduce to 8 squared is 64. B squared is our unknown. 100 squared, or 10 squared is 100. So that makes B squared equal to 36. If you take the square root of both sides, that would make B equal 6. So we can now fill in our third side length is 6. Now that we have all 3 sides, we can create our ratios for our trigonometric identities. So for sine, if you look back at 32A, we are supposed to use opposite over hypotenuse. Cosine, we are supposed to use adjacent over hypotenuse. And tangent, we are supposed to use opposite over adjacent. If you notice, these first 3 are finding the angle theta, which is here in our triangle. So in regards to theta, our opposite would be 6, and our hypotenuse will always be 10 in this triangle. That would be our ratio we set up. So again, going back to 32A, when you were finding theta, we always want to use the inverse identity. So we would use inverse of sine 6 over 10. That is what you would put in your calculator. And you will get an answer. When you round to the nearest degree, you should get 37 degrees. Now for cosine of theta, we're using the adjacent side and the hypotenuse. So adjacent to theta would be 8. It is connected and it is not the hypotenuse. So it would be 8 over hypotenuse, which never changes in this triangle, is 10. Again, use the inverse. So we would do theta is the inverse of cosine of 8 over 10. Put that in your calculator. You should get 37 degrees again. The reason we are getting the same thing is because we're finding theta each time. We're finding the same angle, so we should get the same answer. For tangent, we're using opposite and adjacent. So your opposite is your 6. Adjacent we said is our 8. So again, using the inverse, so theta equals the inverse of tangent, 6 over 8. You should again get 37 degrees when you round to the nearest degree. So that gives us our final answer because we got all the same things. It's 37 degrees for theta. Okay, now the next 3 in our chart are talking about alpha. So we are now doing the angle alpha, which is here in our triangle. So our opposite and adjacent sides will be different this time, but the hypotenuse will still be the same. So for sine, we are using opposite over hypotenuse. So opposite of alpha would be our 8 over our hypotenuse is still 10. So now alpha equals the inverse of sine, 8 over 10. And that should give you 53 degrees when you round to the nearest degree. Okay, cosine is adjacent and hypotenuse, so the angle or the side length adjacent to our alpha angle is 6. It's the one that's touching the angle, but it is not the hypotenuse. So we would use 6 over 10. So again, using the inverse, so cosine inverse, 6 over 10. Alpha should be 53 degrees when you round to the nearest degree. And our last one, tangent, is opposite over adjacent. So our opposite of alpha is 8. adjacent was 6, so alpha is inverse of tangent 8 over 6, which you should get 53 degrees when you round to the nearest degree. So we got 53 degrees each time, giving us our alpha angle is 53 degrees. So if I go back to my triangle, I can label this information. If I erase my scratch marks, I can say that alpha is 53 degrees, and I can say that theta is 37 degrees. Okay. Another good way you could check yourself, make sure you are correct, is if you add all your angles together, you should get 180. So if we added 90 plus 53 plus 37, that does equal 180. So that is a good way to check yourself to make sure you have gotten the correct angles. Alright, moving down to the next piece. We need to find the missing sides and angles of this triangle. So let's start with finding theta. We have two of our other angles. We know that this is 90 degrees and this one is 25 degrees, obviously, because it's telling us. We know that all three of our angles have to add up to 180. So we can create the equation of 180 minus 90 plus 25 has to equal theta. So if you put 90 plus 25 in your calculator and then subtract that from 180, you should get 65 degrees for theta. Okay, so that is one variable. Now we need to find x and y. So I'm going to find x next. To find x, I'm going to use this angle 25. And x is opposite of 25, so I need to use a ratio that has opposite side length in it. First one that comes to mind is tangent, but sine also uses 25, so you could use that one if you wanted to find y first. So I'm going to use tangent of 25, and that equals opposite over adjacent. So if I rewrite this, opposite 25 is x, and adjacent 25 is my 7. So now I'm just using algebra skills to solve this. I need to multiply by 7 on both sides, so those 7's cancel out. I'm left with x. When you multiply tangent 25, make sure you put parentheses around it in your calculator and then multiply by 7. You should get 3.3 as your rounded answer. So in my diagram, x equals 3.3. And lastly, we need to find y. So I'm going to use Pythagorean theorem because I already have two sides of my triangle. So I'm going to do 3.3 squared plus 7 squared equals y squared, because y is my hypotenuse. When you put this in your calculator, you should get y equals 7.7. Once you put this piece in your calculator, don't forget to take the square root of it to find y. That is it for that one. You can label this in our triangle. Alright, last independent practice problem. We're finding the missing side and angles again. So again, we have two angles. We know that this is 90 degrees, and then we know that this one is 71, obviously. So to find our theta, we would do similarly to above. 90 plus 71 equals theta. I also encourage you guys to pause this video, try this on your own, and then watch this back and see if you guys got the correct answers. For this one, once you put that in your calculator, you should get 19 degrees for theta. Next, I'm going to find x. So x, I'm going to use I have my hypotenuse this time, and x is opposite my 71, so I'm going to use sine, which would be opposite and hypotenuse. So I'm going to use sine of 71 degrees equals my opposite over hypotenuse. So if I rewrite this, sine 71 degrees, my opposite would be x, my hypotenuse would be 11. So I need to multiply both sides by 11. So those would cancel out. I should get x equals 10.4 for x. And lastly, for y, I'm going to use Pythagorean theorem again because I have my other two sides. So I'm going to use 10.4 squared plus y squared equals 11 squared because 11 is my hypotenuse. And once you simplify that, you should get y equals 3.6 as your answer. And that is all for 32B. Go ahead, then teacher talk is essential, so you will want to do that with one of your teachers.